Hi, good evening. I'd like to welcome everyone to the dinner talk tonight on very important topics. The first one will be very interesting because it's the first one. And I myself is Wuttinan from GMEC, and I'm also affiliated with TSPCA. So I will first start introducing our speaker, and thanks to Jan that she's getting up so early. It's like 6 o'clock in the morning over there. So, well, for over 35 years, TechSearch International has been the world's leading research and consulting firm specializing in advanced packaging, where Jan is working and as a founder. And well, Jan is an IEEE distinguished lecturer and IMAPS fellow, and has received numerous awards, including the Distinguished Achievement Certificate from Technical Leadership just for last year. Over the next 18 minutes, it's a very, I think it's a not very long talk, but you will see the insights. Jan will share insights on advanced packaging technologies, critical roles in supporting AI infrastructure, but more importantly, how it will shape Thailand's future in advanced packaging and semiconductor. So, well, after the video, Jan herself will introduce the company, and also will be followed by question and answer. So let's start the presentation by Jan. Yeah, please welcome Jan.
Hi, everybody. Thanks for inviting me to speak to you today. I want to talk to you a little bit about the infrastructure for advanced packaging. And we're going to talk a little bit about what's Thailand's role in this. So if we look at how the packaging has evolved over time, we basically moved from legacy packages like wire bond and lead frames to a lot of advanced packaging. Things like stacking the die inside the package, wafer level packages where we fabricate everything while it's still on wafer level, package on package, stacking packages, system in package where we put multiple die in a package, and even flip chip on a laminate substrate, and sometimes even die-to-die connections without even any solder bumps between them, where we call hybrid bonding. So we're stacking die with that connection. So it's a continuing story, and a lot has happened over the last 40, 45, 50 years. So today what's happening is a lot of our packaging is being driven by the growth in data centers. That's what's driving basically our growth and AI hardware growth. And this is probably going to continue despite some concerns, because applications that are being used are like providing AI services to organizations that can't build their own models, managing very large amounts of data like commercialization of 5G services, smart factories, medical, where we look at all the imaging, all of the data gathered from the journals, that research journals and doctors can drill down into selecting only the ones that are relevant to their immediate needs for reading. Military, lots of different military applications, streaming platforms, enterprise operations. So all these things that we can use AI for are driving us to develop and build more and more data centers. And these are being built by companies like the cloud service providers or hyperscalers like AWS, Microsoft, Google, Meta, Alibaba, Tencent, ByteDance, Oracle, and others. Now, along with building that data center, there's a lot of infrastructure that has to support it. Test equipment suppliers, like we're integrating a lot of the automated test equipment and system level test, because everything has to be tested before it goes in the data center. Everything from the IC to all the way to the system. The EMS companies, where we assemble a lot of those boards for the data centers, sometimes fiber attached. We'll talk a little bit about that later. Fiber attached for co-packaged optics. Printed circuit board makers and related supply chain portions, such as the copper-clad laminate suppliers and resin makers. These AI servers have very high layer counts. Say, in the case of many of these PCBs, it's like 20 to 30 or more layers. as opposed to just a general CPU server with, say, 20 layers. And a lot of times we may need more use of high frequency and high speed transmission materials for those printed circuit boards. So a lot of activity there. Power modules, we're seeing more in the embedded die area. Capacitors, a lot more capacitors, say where we might have 2,000 capacitors per motherboard. An AI server, some people have anticipated might need as many 200,000 capacitors, a lot of capacitors. And then storage devices. So let's drill down for a moment and look at what these complex AI packages are. First of all, there's a lot of challenges with building these. And remember that AI is a combination of hardware and software that enables our high-performance computing. And it's this complexity of packaging that's driving new developments in technology like materials and substrates and package configurations. And it's also driving our printed circuit board developments. So if we look at where we are with this AI training and inferencing packages, we see that basically as our infrastructure grows, so does the demand for these packages. And UBS estimates that the infrastructure for AI is going to account for about 375 billion this year, and maybe there'll be 500 billion next year spent on the global AI infrastructure. And these training and inferencing packages are just one part of that. They're very small unit volumes, say only 5.6 million units shipped last year. And that's a small number compared to what you think about mobile phones, smartphones, where there's like 150 to 200 packages per phone, and we shipped at least 1.5 billion of those. So it's a small number of unit volumes, but these volumes are high dollar value. These things sell for $30,000 to $40,000 each. Now, NVIDIA is the major player, but we have AMD closely following, and then others are entering the market. And this market's going to grow. With this data center growth, we're going to need more training and inferencing packages. And so we estimate that it's going to be up to, say, 18 million packages by 2029, which is a tremendous amount of growth. Now let's look at what one of these packages looks like. So basically, it's a GPU plus an HBM on an interposer that's attached to a build-up substrate. So the Hopper is one of the examples that I'm talking about here from NVIDIA. And you can see from this cross-section, here is the GPU up at the top. And you can see that that's attached with small copper pillar bumps that say 54 micron bump pitch to a silicon interposer. And next to it is an HBM. And that HBM is going to communicate through the silicon interposer to this GPU. And in the case of this package, the GPU was a very large GPU. You can see it in the center down below in this package. It's about 812 millimeters square, which is almost the size of a silicon reticle. And then you can see that there are 6 of these HBMs around it. And so each of those has 8 DRAMs in it plus a logic layer. And this whole buildup substrate that it's attached to, the silicon interposer, is attached to it with these C4 bumps. You can see the bumps right on the bottom of that silicon interposer. And that is attached, they're about 120, 130 micron pitch. And this buildup substrate's fairly complex. There's a core in the middle and buildup layers on each side. And in this case, it's a 58 by 55 millimeter buildup substrate supplied by EBIDIN. Now, the power consumption of this thing is a lot. It's around 1,000 watts. And it's going to get even higher with future generations where we are today with Blackwell and Rubin in the future. So this is a very complex, high power package. So if we look at the AMD Instinct, which is another basically supplier of these AI hardware, inferencing and training packages, basically they incorporate their GPU and logic in a little bit different format. They break the die into chiplets and attach those together to improve their power performance. And it's still attached to a silicon interposer. That interposer is about 60 by 50 millimeters. It's the largest silicon interposer in production. The package size is around, the buildup layer that goes on that is about 77.5 by 62.5 millimeters. And so this whole package is then used in as a training or inferencing module. So this is very complex package. It is the largest silicon interposer that TSMC makes today, largest one in production. But moving forward, what we understand from TSMC and others is that while the silicon interposer is very mature, and it's gone up to more than a 3.3x reticle size for the silicon interposers in production today, it's basically, as we want to use more and more of those high bandwidth memory modules, we're going to need to shift to an RDL interposer to support that. And that interposer consists of layers of copper and polymer. And there are many, many layers. You could have as many as 9 layers in that structure. But maybe you don't want so many layers to support this routing between the HBM and the GPU, the logic device. So you would put a bridge in that structure so that you could support those many HBMs and the communication between the logic and the HBM. And so we have now moved into RDL interposers in production. So what we see today is NVIDIA is shipping this Blackwell. It uses TSMC chip on wafer on substrate with a bridge, which they call an LSI. And that's using, as you can see down here, there's an RDL interposer. It's replaced the silicon. So this is the RDL with molding. And basically, you can have this LSI here that can be used for the communication, high density communication. And maybe there's only need for like 4 RDLs. And so this is then attached, just like the silicon interposer was, to that substrate. And then the substrate's attached to the board. So when we get to the next generation, the Rubin Ultra, we're expecting to see like 12 stacks of HBM, maybe HBM4E, that'll be a big, big, big 5.5 reticle size interposer attached to an even larger 100 by 100 millimeter substrate. You can see the Blackwell part right here. And you can see already there's 8 of those HBM devices. There's 2 of the GPUs that communicate with each other. So these are getting more and more complex. Now, the AI hardware module is more than just logic and HBM. This package is going to go onto a module where there's lots of passives, capacitors, and voltage regulators. And you'll see that the key supplier of voltage regulators includes companies like Infineon. They're key suppliers of capacitors for AI applications that include Panasonic, Simco, Murata, TDK, Kyocera, AVX, Yego, Empower Semiconductor. And a lot of these components, especially some of the high voltage components, are embedded in substrates or PCBs. And you have companies like Access in China, AT&S, there's a Europe-based company with their embedded technologies, and TDK. There's also a lot of connectors used to connect this to the next level. Those are provided by companies like Amphenol, Samtec, TE Connectivity, and Molex. And as I said, these PCBs have higher and higher layer counts. They're from TTM and people like others, as much as 20 to 30 layers in them. So if you look at these power stages that are being used for these applications, you can see that they're basically talking about using embedded power stages for these to regulate the power consumption. And basically, these training and inferencing modules use like 48 to 64 power stages with maybe 80 in the H100 and more than 100 power stages expected in the future. And what we're seeing is these power stages are increasingly being packaged in panels or in an embedded die structure. So this is basically a little bit of a shift in the technology moving forward. Now, one of the things that we've noticed and the industry's noticed is that we have a problem. These data centers, electricity consumption has been growing dramatically. Remember, I told you that these are high power dissipation devices. And this has been driving our electricity consumption to increase by 12% per year to support this demand for these higher power devices. So what we need is an improved I/O power efficiency in our data centers, especially these hyperscale data centers. So we've had people talk about switching from a pluggable optical solution, which is for the switch. And these switches are basically on the top of the rack, the whole racks that are in the data center servers. And they're today mostly a pluggable solution. They traditionally dissipate about 30 watts of power. and it's an external optical transceiver that's being used. But moving forward, we're going to see more use of co-packaged optics. And one of the drivers for this is because it's lower power. NVIDIA tells us that it can reduce the power from 30 watts to 9 watts. So that's a big power saving by shifting to co-packaged optics versus the traditional pluggable solution. Because what's happening is that signal is coupled to the fiber almost immediately instead of traveling over long distances. And the electrical loss is less. So this is going to be a very important development moving forward, and we hope that that's going to help with our power reduction. So let's look at what's in Thailand. What does Thailand have today? Well, we see at least 6 OSATs in Thailand operating, and they could be Hana Microelectronics, Hana Semiconductor, STARS, UTAC with 3 plants. The assembly capabilities are focused typically on the lead frame products, some MIS substrates, and even some optical packages. We have a lot of industrial and automotive grade packages that are in lead frames from PQFNs, QFNs, DFNs, some of those being flip chip, MEMS, and a little bit of wafer level package. We have a lot of final test capabilities to support these turnkey operations. But what we don't see is a lot of bump, advanced packaging, and panel level packaging offered in Thailand today. If we look at the EMS, the printed circuit board assembly, we found at least 15 factories from well-known companies that you're all very familiar with. And FiberNet, we recall from some of our folks visiting there years ago, was doing a lot of optical assembly. And so there's a lot of capabilities here in assembly at the EMS side for the printed circuit board assembly. So very good capabilities. And of course, we know that more and more printed circuit board companies are coming to Thailand to set up operations. So what could Thailand offer in more of advanced packaging moving forward? Well, it's possible you could do the RDL interposers. Right now, that's also called a high-density fan-out on substrate, and that's going to increasingly be used instead of the silicon interposer. And you can see here is an example of one, again, where you see your logic device, and here's your RDL interposer, and here's your HBM. And these are going to communicate through this RDL interposer. Maybe there's a bridge in there to help communicate. But these are very high density parts, and you're going to use this more and more in the future. Now, there are a lot of companies that offer interposer solution. TSMC offers these in Taiwan. Amkor offers their version. They build them in Korea. ASE has versions built in Taiwan. IBM licensed THECA's RDL process, which can be licensed by others, but they're putting that in North America. JSAT has their own version that's in China. Samsung has their versions that are in Korea. And SPIL has versions that are in Taiwan as well. And so you could do something like this. You can license technologies and put this in place. You could also look at the packaging for power devices, because power devices are very important to a lot of these applications. Things like silicon-based MOSFETs, copper clip packages, MIS packages, the molding interconnect substrate packages. And increasingly, we're seeing gallium nitride adopted for high-frequency, high-voltage applications, such as your AC-DC conversion, and for uninterruptible power supplies for industrial motors, photovoltaic converters, communications equipment, and data centers. And a lot of times you'll see people talking about having these data centers powered by solar. So a lot of new application there. Some of this is in the conventional technologies like a lead frame, like a DFN or a QFN. But we also see a lot of these being adopted in the copper clip versions of power MOSFETs. And then we've had DC-DC converters being put in place in a panel line, a large panel line by companies like Phoenix Pioneer Technology, PPT in Taiwan. And so this technology could also be put into Thailand as well. So we have a lot of possibilities that could happen. So in concluding, I'd like to say that we think AI growth is probably going to continue. It's going to drive the demand for this AI training and inferencing. And whether you build those training and inferencing modules or whether you provide the support that goes along with it, there's a lot of opportunities here. Those packages are going to change over time. We're going to see more use of RDL interposers with and without bridges. We're going to have a lot of packages to support this infrastructure, including power packages in a lot of formats. And there's a lot of challenges we need to work on. Better power efficient solutions for the high performance applications, new thermal solutions and materials. So a lot of work to do. So with that, I'd like to thank you very much and hope you have a wonderful evening. Thank you.
Okay. Well, thanks very much, Jan, for the video record and also for waking up so early. Now Jan is live with us. Can you hear us? Hi. Okay. So before we move to Q&A session, I'd like you to give you a moment to introduce who is TechSearch International and what do you do? Yeah, please. Yeah.
Hi, I hope everybody can hear me okay. So thank you for having me speak to you virtually this evening, your evening, my early morning. So our company is 38 years old. We are focused solely on the developments in packaging, which we've been following for quite some time.
Just one moment, I will bring up the slide so the audience can see the slide as well.
Okay, thank you.
Okay, here we go. Can you see the slide?
Thank you. Yes, I can. Thank you for having me here and joining you live from early morning Austin, Texas. So our company's really focused on advanced packaging. That's what we've done. And if you'll flip the next slide, I'll give a brief introduction of what we're offering these days. A lot of what we do is focused on reports and following the developments of the industry. For example, we just published a report that really describes everything in advanced packaging with a focus on the flip chip and the wafer level packaging. And these are areas that are being used today for a lot of different applications. So we cover those and talk about what are the trends, what are the market drivers and things like that. We also do some licensing where our company has worked with people that want to license technology, but primarily we're publishing the reports to help guide people on what's out there, what's happening. You can see what's been licensed by other companies in these reports. And so that's one of the major things we do. And so there are a long list of the different reports that we've done, and we just make those available. After people order them, they download them and read them. And then we're often asked to answer questions or maybe provide a seminar or something like that on these reports. So that's our primary business. And in our licensing technologies, we've actually licensed technologies from Japan to the U.S., from the U.S. to Taiwan, all over different places. So it's, and we travel to many different countries to look at the operations there, to tour the factories. That's how we gather a lot of our data.
Okay.
So if you look at what we focused on, I really appreciate the time to talk to you a little bit. And I'm happy to answer any questions that anybody might have, because I think that the way that we focused on the emerging areas, the most important things that are happening. And we are just at a really exciting time in our industry where we're seeing a lot more emphasis on the packaging side. While the silicon is very important, it doesn't happen without the silicon. So I'm happy to answer any questions if you have any questions about our company or what we see in the future.
All right. Thank you, Jan. Thank you very much again for the video and the introduction to the company. So now is time for Q&A. I'd like to open to the floor. Anyone would like to ask a question, please raise your hands, please. Okay, so while we are waiting for questions, I have some prepared questions. So regarding the government support strategy, based on your experience working with the countries like Singapore, Malaysia, Taiwan, and China, so what should the Thai government like prioritize to accelerate the advanced packaging industry growth? And maybe could you share specific example from these regions, the countries? Yeah.
Well, thank you very much for the question. You know, Singapore did a lot of bringing in of companies through various tax policies. So that's how they have brought in some of the operations there. And those favorable tax policies encouraged companies to locate operations there, and also R&D facilities there. There's a lot of work in conjunction with the IME Star program that's there, the Research Institute. And Applied Materials did a lot of their work on some of their recent equipment developments with their Kinnext product for hybrid bonding. So a lot of support in that way. In China, that's a long history. They've had a large government-funded programs. They've done a lot of technology licensing and government support to the industry. That's been historically, it's really happened over the last 20 or so years or more, 30 years, we've seen a lot of advances. In Taiwan, a lot of the activities originally stemmed from one of the research institutes there called ITRI. ITRI was actually where TSMC came out of, and most people don't realize that Morris Chang, the founder of TSMC, was actually an employee of ITRI. He was basically a Taiwanese government employee when he was getting TSMC started. And of course, we know how successful TSMC is. But in Malaysia is getting going with their programs. They're very heavily invested in some of the same type of operations that in lead frame assembly and things like that that is in Thailand, but their government is also interested in moving into more advanced type of higher value of the packaging. And so they're just getting some government programs started in this area. Now, I think that one of the most important things is the talented people in your country. And probably you want to encourage those people to stay and to perhaps with some type of research organizations that can demonstrate or be an operation where companies can come to develop new ideas. I think that in the U.S. we've seen that small business incubators have helped our people get their ideas moved into the marketplace. And the most important thing is to understand the market and what the market drivers are. But I mean, it takes a lot of different factors. I think it takes the government putting the right environment together, the right, perhaps some funding, tax policies. It takes a talented pool of people, and that can be encouraged through your universities, through your research organizations, and supporting all of that. And it's that combination of factors that enables countries to develop. So I think that we're certainly seeing a lot of countries around the world try to improve their economic situation to support this industry, and continued policies to support that. And I think that's going to have a positive effect on our industry as we move forward. And hopefully that can happen more in Thailand as well.
Okay, thank you. I think there's a question from the audience. Maybe could you, please tell us your name.
Okay, yeah. Thanks a lot, everyone. This is Nat from Star Micro. And hi, Jan. You should be good morning from there. All right. My question actually related to the BOM, right? The wafer BOM and the advanced packaging solution that currently is not yet offered in Thailand, right? How do you think that with such technology can, if it really happen in Thailand, how this thing can contribute to Thai value chain, maybe whether it can cross the gap of the whole, IC packaging, advanced packaging, supply chain. Yeah. What do you think that with that such a technology, how it's going to be benefit to us? Thank you.
Yeah, thank you for the good question. I think what you want to do is you want to build on your strengths. I mean, right now, you're seeing almost an announcement every few weeks or months with a company that's moving their printed circuit board operations or opening some printed circuit board operations in Thailand. You also have, companies that have capabilities with optoelectronics assembly and fiber attach, and that's very important. I think that perhaps what you want to do is, I wouldn't suggest that you need to put in a semiconductor fab, that the infrastructure is probably not in place for that. And it takes more than just a semiconductor fab. So I think that you should build on some of the strengths that you have, expand the offerings of companies into more advanced assembly that would be higher value, higher margin. What we see in some of these advanced packaging is that the margins are so much higher. And so that may be through technology licenses, but those are possibilities.
Okay, well, thank you so much for the comprehensive answer. I think we are running out of time. I'd like to conclude the session by thank you again, Jan, for... oh, that's another question, I'm sorry.
Hello, can you hear? Hi, my name is Prapin. I'm
Yes.
the president of Thai Automation and Robotic Association. Okay, given your answer, and given that Thailand, we have been lag behind in investing in, this industry, and given you told us, you suggested the answer, what do you think Thai government should put effort into support in order to get Thai industry started, in this big industry, but focus in which area? I just like to know your opinion. Thanks.
Thank you. Well, you're from the robotics area. I mean, one of the things that we've noticed in all of these factories that are going in now is high levels of automation. So if you can build the automation, build the robotics that goes into some of these operations, then you play a critical role in the industry and can expand your offerings as well. So that's an important part. You may want to encourage companies to come in and partner with your existing companies to move to next steps in some of these areas. And I think that's really what's been done in some of the other countries, is that, it is a global industry. And by partnering, you may be able to invite companies to come in and expand operations, your existing operations. And of course, I think you absolutely have to have the appropriate tax incentives to get people to set up operations, or to, maybe you want to structure licensing technology deals where the government is able to pay for part of the licensing fees and provides the environment necessary to bring in a next technology, whether it has to do with some assembly process, or whether it has to do with, in the automation field, building the equipment for it, because those are areas that I think are very important moving forward. So I think that it's a broad brush that you need to paint with.
Okay, I agree with that. But what about
So
in
I
the
hope that helps a little
semiconductor
bit.
area where we are not good at? What you're talking about is about packaging.
Well, the semiconductor area, I mean, the people can, the U.S. doesn't have a lot of semiconductor packaging, nor does Japan. Yet they play a key role in the industry. So you don't have to have a semiconductor manufacturing fab to participate in this industry. You can provide something else, because the fab actually requires a different set of skills, a different ecosystem and infrastructure to enable that. And I think that you have other parts of that infrastructure, such as building the equipment, like, for example, what's done in Singapore, in the development of that equipment. You have a lot of talented people. I think you have some, good business already that started, and you can build on that to support the rest of the ecosystem. Because supporting the whole ecosystem is very, very important. And you don't have to just have a fab.
Okay, agree, clear, thanks.
Thank you for the question and for the answer, Jan. But I will have another last question from the floor. Yeah, please. Yeah.
Morning, Jan. Dave Bergman, Global Electronics Association. Thanks for the presentation. My question is related to the breakthroughs in advanced packaging that you've seen over the years. The role of the consortium in those, do consortiums play a major role in it, or is it normally a lead organization that is carrying or driving the rest of the industry with them?
Thank you for the question, Dave. It's good to see you there. We have examples of both cases. There are examples where consortia has really spurred things along. I think ITRI is a very good example in Taiwan in its long history. And as I mentioned, that was really what helped TSMC get started. I think that in some cases they continue with their activities. We've certainly seen the research organizations like CEA-Leti in France and IMEC in Europe that's enabled the portions of the industry going along. I mean, I think that ST benefited a lot from the developments in the CMOS image sensors with their work through CEA-Leti. So they're examples of research consortiums, and that may be, for example, if there's a big robotics industry association in Thailand, then maybe you can focus on ways to improve automation. And that may be important where you become a center of developments in automation and automated equipment that's used in all types of factories. And the use of AI is increasing in that. So maybe there's a center that helps to promote that and to promote the development. And then you become known as the automation area in Thailand. So I think that there are examples of where you can have a lead company that comes there and sets up operations like Applied Materials did in their research center in Singapore, or where you have them work with an organization that the government helps to set up to do research in a key area that you want to develop in your country. So I think you have to carefully study what are your key enablers at your country level. And I don't think that is one answer necessarily is going to provide, is the answer for every case. So it's kind of a case by case, but there are examples of both.
Thank you, Jan.
Thank you, Jan. I think we are running over the time now. So please give her a round of applause, please. Yeah. Thank you, Jan. And we hope to see you in person very soon, hopefully early next year.
I'm looking forward to it.
I think many people from representative from companies really like to see you in person. Yeah. Thank you. Bye-bye.
Thank you. Thank you very much. Have a lovely evening. Thanks.